Okay, so what we were doing in 1.5 last time, we were doing transformations. So what I'm going to do on this is I like to kind of show students how to do this with a table. You don't necessarily have to do that, but it's a good way to organize your information. So the first thing I'm going to have you do here is the elementary function is a square root of x, and we're going to do transformations on that. So and this kind of thing you can do in your head. We just try to pick, 3 or 4 points on the elementary function, okay? So if you got a square root of x, what's the smallest value I can pick for x if it's a square root? 0, okay? Then just choose, probably that's good enough, just 0, 1, and 4. Let's go ahead and pick 9 also because we can do that in our head. Then you're just doing square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and so forth. And what I'll have you do, to begin with, just go ahead and plot those points, and then we'll go through how the transformations work then, okay? So we're going to plot 0, 0, 1, 1, 4, 2, and 9, 3 like that, okay? And the more of these elementary functions you memorize, at least the shape, the better, but it's easy to crunch out a table of values on these when you're doing these then, okay? Now, let's see what we kind of remember from last time. Tell me what the x minus 2 does. What does that do to the graph? It's in the function, so what did we learn?
Horizontal.
Yeah, this way, right 2. Horizontal, right 2. Let's kind of write these things down as we go. So we got right 2, okay? And tell me what the plus 3 does. That's outside the function. How's that move it? Up 3, okay. So that's up 3. Got to know where everything is. And then the last one is the 1/2. What does the 1/2 do? Does something to y. Okay. Anytime you're outside the function, it does something to y. That multiplies y by 1/2. All right. So a good way to think of this is just multiply y by 1/2. But what that does is the y values get cut in half. What does that do to the graph? Kind of shrinks it, okay, vertically. So we call that a vertical shrink. Okay, like that. And then we're going to put this together then, all right? So you want to know those transformations and be able to identify those. Then we're going to fill out kind of a chart on this. Now, you have to do these transformations in a certain order. And what you do is you follow order of operations. The thing is, the first thing that you would do is you would have to do what's under the radical. That would be the first thing. Second thing would be to do the 1/2. And then the last thing is the adding. And the reason I'm doing that is I'm following order of operations. I'm doing a grouping symbol, which is under the radical. Then I'm multiplying. Then I'm adding. That's how I know that. So what I'll have you fill out in the bottom, we're just going to kind of make a column on here. The first thing we're going to do is move everything to the right 2. Okay, then what we're going to do is we're going to multiply the y values by 1/2. Okay, and then the final thing that we're going to do is move everything up 3. Okay, and then we've already got these points here. So we had 0, 0, 1, 1, square root of 4 is 2, square root of 9 is 3. Okay, everybody with me so far? Okay. Now, the reason I like to teach it this way, this kind of shows you the order you have to do the transformations. And then if you do it this way, you're kind of organizing everything nicely. Okay, if I move something to the right 2, what changes, x or y? X does. X gets bigger by 2. So what you want to do, you just do all this work in your head, is take all those x values that I highlighted and make them get bigger by 2. Okay, so 0 times 2, that's going to be 0 plus 2 is 2, 1 plus 2 is 3, 4 plus 2 is 6, and then 9 plus 2 is 11 like that. Okay, the y values don't change in the first step. It's only x that's being affected. Okay, so that's how you do that. Okay, next thing we're going to do is we have the vertical shrink. Okay. And what you need to do on the vertical shrink, do you change x or y? Change y. You just take half of y. So what you're going to do next is take all of these y values, and just cut them in half. Okay, you're multiplying that by a half. So you would have half of 0 is still 0, half of 1 is a half, half of 2 is 1, half of 3 is like 1.5, okay, like that, okay? And you can use a decimal if you want to, and then the x's are unaffected, so just bring the x's from the previous step so that you have that, all right? All right, everybody with me okay? As long as you know the order of what you're doing and what the transformations are, there's really nothing to it. And then the last thing you do is you take everything up 3, so what changes, x or y? Y. If you're taking everything up 3, that's a y measurement, so what you're going to do next is take all those y's and just make them go up 3. So 0 plus 3 would be 3, a half plus 3 would be 3.5, 1 plus 3 is 4, 1 plus 5.3 is 4.5, okay, like that, all right? And then the x's just, we set those in the first step anyway, and that's it. So this group right here, that would be the final points you plot, and then you'd have your transformed graph, okay, like that, okay? Now, as a student, with practice, you can do a lot of this in your head, but this is just a good way to keep track of everything. So go ahead and plot these points down, and then we'll see if this kind of looks the way we think it should. So I'm going to go over 2 up 3 for my starting point, over the 3 and up 3.5, okay, then over 6 and up 4, and then finally way out here at 11, up about 4.5. So that's about what that graph looks like, okay? So if you look at the graph, you can tell that we went to the right 2, like this point went to the right 2 and up 3. Can you see that it got shrunk? It's kind of skinnier, isn't it? The swoosh is a little skinnier, so basically everything, the y values are half as much. So one thing that you'll kind of notice on here, notice in the first step, the y values were off by 1. Now they're off by a half. That's kind of a good connection to make. At 0, 1, 2, 3, those things go up a half. That's what that did. Does that make sense? Okay, all right. So that's kind of how you can do that. What they have you do on your homework on My Math Lab, I think they have you kind of do that final group of points on there. And then you can do that methodically like that, and then you'll kind of understand, I think, the transformations better. Okay? All right, now let's do the domain on this. So look at, to find the domain, all that matters is we have x minus 2 in our problem, right? What do you do with the x minus 2 to find the domain? It's real simple. What do you do? Set it greater than or equal to 0. Thank you. Okay? So if you're going to find the domain, you just do that. You can do that in your head. You can tell the blue graph starts at 2. Then you can add 2 to both sides. So you would get x is greater than or equal to 2. Okay, so the domain will just say in interval notation, bracket 2 to infinity like that. Okay? Now the range, you just want to look at the graph we did. So what is the lowest value y ever hit on my final graph? 3. Okay, so it's 3 and bigger. So when you're doing the range, you need to look at the graph to figure that out. So the range would just be bracket 3, comma, infinity like that. Okay, that's it. Okay? Any questions? Everybody following what I did there? Okay, all right. Until it's 8 in the morning. All right, let's move to the next thing here. I'm going to do probably just one more of those, but just to in a little bit different way. On this next page, I just want to kind of go through the transformations. This is a summary that you can look at, but these are the basic transformations that you need to know. And so let's just kind of identify some of these on here then. You'll do a little bit of this on your homework also. All right. So this is a parabola. You would want to know that x squared is a parabola. What does the minus 8 do? Tell me what that does. Say something. Right 8. What is is that a minus 9? What's the minus 9 do? Down 9. Good. Okay, so that would just be right 8. And then down 9. Remember, if it's inside the function, it's left, right, x value stuff. And if it's outside, it's y value stuff. Okay? Next one's the same thing. What does this do? What are the two transformations on the next one? Right 9, up 1. Okay. Okay, these are all pretty simple here. Okay, and then the next one, oh, hold on. Does that have a negative? Yeah. What does that negative do right there? Okay, x-axis reflection. Okay, so you would, and if you say reflect, you got to tell me which axis it flips over. Okay, and the way to know that is it's outside of the function, therefore it's making y opposite. So it's changing a y value to an opposite, which is what causes it to flip over the axis. Okay, and then the next one, what does the x plus 4 do? Okay, left 4. Okay, and what does the minus do? Same thing as last problem. Okay, that's going to be reflect over the x-axis, like that. Okay, so that's kind of the way that you want to make sure that you can look at a function and tell what all the different transformations are. Okay. Okay, so that we've done most all of those now. Okay, let me go down at the bottom here, and what we want to do on this is we're taking this elementary function. We're just doing this backwards. I'm telling you that we're going to take it to 8 to the left and 3 downward. Okay, so the final result on this would go like this. We'd say f of x equals, all right, what do you need to do to make it go 8 to the left? X plus 8 inside the function, right? So it goes there. That's what's taking that to the left 8, like we learned. And then 3 downward, what do you do? Minus 3 outside the function like that. Okay? That's the idea. Okay? Now let's see. The next one, we have absolute value of x. We're going to vertically stretch it by 2. And then we're going to reflect it over the x-axis. Okay, what do you do to make the absolute value stretch vertically by 2? What do you do with the 2? Where do you put it? In front, okay, because you're multiplying the y values by 2. That's how you do that, okay? And then reflected across the x-axis, what do you do? Put a minus right there. That's it, okay? All right, you guys feeling okay with what I'm showing you on transformations? Okay. If you had a good background in high school and pre-calc, you would have learned this kind of stuff. So it's just a matter of knowing where the numbers go and how they're affecting x and y is the key thing. Okay? Any questions about anything so far? Okay. Now, I'm going to do one more, I think, on the next page. This is just sort of generic. And if I give you a function, I don't actually give you what the function is algebraically, I just give you the graph. This is one of the best ways to check and see if students understand this or not. So what we have is this is just sort of a generic function, and the things that are going on this is we know if it's inside the function, that's going to take you to the right 1. If it's outside the function, adding and subtracting, that's going to take you up 3. And then this thing right here does 2 things. That reflects you over x, and it vertically stretches. The best way to do this is just think of that as multiply y by negative 2. I mean, if I ask for what that transformation is, you would say vertically stretch by a factor of 2. But when you're doing this, the math we're going to do on here, just think about what you're doing. You're multiplying y values by negative 2. Okay, so what we're going to do on this then is, this is the graph I've given you. These are the points. I went through and just identified the 1, 2, 3, 4, 5, 6 points on there. And then we're going to go through and just do this in order. Remember, the last thing you always do is up, down. If you do left, right, that's almost always where you're going to begin. And then the multiply goes before the adding. So it's order of operations. Okay, so that's, you want to make sure that you understand what you do in the order. Okay, does everybody understand that? Left, right first. Why? Because you're inside parentheses. Why the multiply by negative 2? Because you multiply after you do inside a grouping, and then the last thing you do is the plus 3. Okay, so really all you got to do is this. All right, so on the first step, what you want to do, you can go ahead and start on this. You don't have to wait for me if you want to. Just make all of the x is bigger by 1. You can do all that in your head. And the first step, you're not changing y, so just make all those get bigger. So that would be -3, -2, -1, 1, 4, and 5. Okay? The y values do not change in step 1, so I just bring those down. Okay? And then step 2, what you're going to do is multiply all the y values by -2. You can do that in your head. I just multiply by -2, double and change the sign is what you're doing. Okay, so 0 times -2 is 0. 2 times -2 is -4. So you have that. 0 times -2 is 0. -1 times -2 is 2. And then 0 times -2 is 0 like that. Okay, so that's what you're doing next. That's causing the graph to reflect because the y values are going to opposites, and it's causing it to stretch. They're getting bigger. Okay, so that would be the group of points that you have in the second step then. Okay, and then the final thing you do is you make everything go up 3. So what you do is just in your head make the y's get bigger by 3. So it looks like 0 plus 3 is 3. -4 plus 3 is -1. So you'd have that twice. 0 plus 3 is 3. 2 plus 3 is 5. And 0 plus 3 is 3. Okay? And then, of course, you've already got the x values from the first step. That's how you start. And then you want to just go ahead and plot those points then. Okay? Does anybody have a question about what I just did? Yeah.
So specifically the x's and doing the opposite, adding instead of subtracting like it says. I remember you explaining it, but I still don't think that I really understand why you do the opposite.
If you look back at your notes, we actually did a couple of them where we crunched out the two tables, and you could actually see it move over that way. You know, that's one way. So the idea is you really got to crunch it out, I think, to see that. It's not as easy to see as the y values, because the y values kind of do what you're going to anticipate them to do. Okay, so I kind of think of it like this. X is really, in a sense, you're moving it. I think what you need to do, there's not a real simple way to say that other than to look at the functions and see how they move. You actually just have to crunch that out and see how they move. Okay. Like that, okay?
And then on a test, just remember to do the opposite.
Yeah. You got it. The thing is, it's kind of hard for me to think of a simple way to explain that, like I can the y's. But you kind of look at the examples we did. I think you could see those tables moving like that. Okay, that's a good question. So let's see. We'll plot the points and then we're done. So we have -3, 3. -2, -1. -1, -1. 1, 3. And then what? 4, 5. And what was the last one? 5, 3. So I think I got that right. Then you just connect them kind of in order the way it was there. So if you look at this, okay, it's done all the transformations. To me, you can tell it's stretched. Okay, you can tell that it's been stretched vertically. It's been turned upside down, and then everything's been moved right 1 up 3. That's it. Okay? All right. Something like that on your first exam for sure. That's one of the best ways to check students' knowledge of transformations is to do it this way, just with some arbitrary graph. Okay, any questions? Okay, everybody clear? Okay, good. Okay, so that, I'm going to go ahead and shut this off. And then the 1.6 that you picked up, I'm just going to do 3 examples, and these are kind of good